Hi everyone, can you hear me? Okay, that's good, thank you. I feel like time flies so quick. Next week is our last tutorial already. So today we will talk about conditional probability, multiplicative law of probability, and law of total probability. I'm not sure where you got to in the lecture, but I hope that you at least get through here. So first about conditional probability. Let's say probability of A given B. It means that you know B happens, the event B happens, then what is the probability that the event A also happen? If we look at the Venn diagram, let's say this is event A and this is event B, and the rectangle is our whole simple space. Then we know that B happens, which means our focus reduced to this circle only, because outside the circle B, outside the circle, it is B complement, which means that B does not happen. But now we know that B happens, and we want to know what is the probability that A also happen. So B happens means that we only care about this circle. We don't care about anything outside the circle. And inside the circle, where does A happen? A happen in this part, right? Because this part here is not A. So A happens mean that this area. So the probability that A happens given B is this part divided by the whole circle. That's why we have the formula probability of A given B equal to probability of the shaded area, which is A intersect with B, divided by probability of B. Stop me if any part does not make sense to you. This is how you should think about it instead of trying to memorize the formula. It should make total sense to you. And then from here, you'll get probability of B is equal to probability of A given B. Oops, sorry. I mean probability of A and B is equal to the conditional probability multiplied with probability of B. So what you're seeing here is multiplicative law of total probability. And you can generalize it to as many events as you want. The formula that we are having here is for two events, A and B. But let's say you have event A1, A2, up until AN. Then you can write the probability of intersections is probability of A1 multiply with probability of A2 given A1, and then A3 given A1 and A2 up until probability of AN given AN minus 1, AN minus 2 up to A1. So this to generalize the multiplicative law for as many events as you want. You don't have to necessarily start with probability of A1. You can definitely start like probability of AN and then probability of AN minus 1 given AN, probability of AN minus 2 given AN and AN minus 1, and up to probability of A1 given A2, A3 up until AN. This is also possible. Next one I want to talk about is law of total probability. It's really nothing new. For example, if you want to calculate what is probability of A, then if we think about it, A is equal to two parts. The first part is this area, which means A intersect with B complement. Right? Because this part is where A happened, but B does not happen. So it is A intersect with B complement. And the other part that make up A is this one, which is A intersects with B. And we know that these two sets, they are disjoint because one set containing B complement and one set contain B. So they cannot have any common element. These two sets are disjoint. Therefore, probability of A is equal to probability of A intersect with B complement plus probability of A intersect with B. And you don't have to subtract anything just because those two sets are disjoint. And from here, we can use the multiplicative law. Probability of A intersect with B complement can be think of as probability of B complement multiply with probability of A given B complement. So here, A act as A and B here is B complement. So anywhere you see B, you change it to B complement. And I also apply multiplicative law to this term. I would have probability of B multiply with probability of A given B. So what I just wrote here is the third one, law of total probability. That is all you need to know for this section. Is there any question? You really don't have to memorize all this stuff because you can derive them by yourself. If there is no question, I will let you work on question 1. Maybe 5 minutes. I will take up at 2:22. If you have any question, you can put in the chat for me. If you are wondering, the 40 students are in a joint degree. It is not part of 80 students that is in only math. Okay, I hope that most of you got the answer for this question. It is very straightforward. The information that we are given is there are 80 math students, 60 statistics, and 40 are in the joint degree. And we know that the script does not belong to a math student, which means it can only belong to a statistics student or the student in a joint degree. Part 1, they are asking us what is the probability that the script belongs to a statistics student. One common mistake that students might make is they try to calculate probability that a student is in statistics. But this is not entirely correct because we do know some information about the script. We know that the script does not belong to a math student. I will use S to denote student in statistics, N for math, and J is for the joint degree. So we see here that we are dealing with conditional probability. Probability that it is a statistics student, given that the script does not belong to a math student. So we just have probability that the script belong to a statistics student and not belong to a math student divided by the script belong to non-math student. If you find convenient, you can also draw a tree diagram, which might help if you want some visualization. For example, that the student can be math, statistics, or a joint degree. Math is 80 divided by, we have 80 students in math, 60 in statistics, and then 40 in the joint degree. So we have 180 students in total. And for statistics, the chance that a student is in statistics is 60 divided by 180. And the joint degree is 40 over 180. And then if the script belongs to a math student, then the chance that the script does not belong to a math student is 0. Because if it belongs to a math student, then it cannot belong to non-math student. Similarly here, if the script belongs to a statistics student, then the chance that the script belongs to non-math student is 1. And if the script belongs to a joint degree student, then the chance that the script belongs to non-math is also 1. So we can see here that probability that the student is from statistics and the script belong to non-math student is this situation. And the probability of that is probability that is a statistics student multiply with probability that the script belong to non-math given statistics. That is our numerator. And our denominator, we see that non-math happen in 2 cases. This is the first case, and this is the second case. So we will have to add probability of the 2 cases together. The first case is that statistics and non-math. The second case is in a joint degree and non-math. So if we plug the number in, we will have 60 over 180. And probability that the script belong to non-math student, given that the script belong to a statistics student, is 1. Okay, I see a question here. Can you just do PM equal to 1 minus PM prime? Let's see. So you mean this one equal to This one here. Yes, you can definitely do that. Yep, that also makes sense. So probability that non-math is equal to 1 minus probability of math. That also makes sense. So instead of calculating the denominator using this way, you can just use what the students say here is also correct. I will just write out here. This one, if you use the same formula like this, multiplicative law, then you will get this one multiplied with this one. And probability of joint and non-math, you just take the probability in this age, multiply with probability in this age. And if you calculate the number, you will get what you want. Part 2, we want probability that the student is in a joint degree, given that is non-math student. Again, we use conditional probability formula. So joint degree and non-math, you can go in this way, which is 40 over 180 multiplied with 1. In the exam, I recommend you to write out that step by step like this. Like what is the probability of the intersection? We use multiplicative law in order to get that. Just be as specific as possible. So in case that you made some error, you still get partial mark. Let's see. And then I see the students, instead of rewriting the numerator like that, you can do probability of statistics and non-math equal to probability of statistics minus probability of statistics and math. Yes, this one is also correct. For the denominator, we use the same denominator as above because we are interested in probability of non-math students. I will copy this one. Okay, I see another question here. Couldn't you just notice that there are partitions and just write S intersection M complement is just S? Yes, you can do that as well. And probability of math complement is just the other two. Yes, you can definitely do that. Any other question? I will not write the final answer here because I didn't calculate it, but again, in the exam, please write like 4 decimal digits, 4 or 3, depends on what the exam is asking you. If we are good with this question, I will let you work on the second one. In the file that I uploaded on Google Drive, there is a typo. It's missing the percentage in those 2 places. So I fill it in. I will give you 5 minutes to attempt this one. Please let me know if you have any other question. Okay, so here for this question, you see that the probability that Kate get an A grade depends on which course that she takes. So that's why I write down what course she's gonna take first. And then the probability that she get a grade or not depends on that course. So we are interested in what is the probability that Kate will take course 1 and what is the probability that Kate will take course 2. They say that she decides to leave the decision by throwing a dice, and if the outcome is at least 3, which means it is 3, 4, 5, then 6, then she take course 1. If it is 1 or 2, then she take course 2. I see a student answer here. C1 is 4/6. Yes, that's correct. And C2 is 2/6. Okay, that's good. Because you can see that when you roll a dice, then you have 6 possible outcomes. And 4 of them will lead to Kate taking course 1, and 2 of them leads to Kate taking course 2. So that's why it's 4/6 and 2/6. And if Kate take course 1, then the probability that she getting A is 25%. Which means probability that she does not get grade A, given that she take course 1, is 75%. Similarly, if Kate take course 2, then probability that she get an A grade is 40%, and not A is 60%. When you draw a tree diagram, you should make sure that at each point, all of the branch probabilities should add up to 1. Like 4/6 plus 2/6 add up to 1. 25% and 75% add up to 1. If they do not add up to 1, unless you intentionally omit, like not include some option, then it's fine. But if you realize that you include all the options there, but the probability does not add up to 1, which means that your tree diagram is having something wrong and you should recheck it. Another thing I want to talk about is the probability in this branch. It does not mean probability that Kate take course 1 and getting an A grade. It is not having that meaning. The meaning of the number here is probability that Kate got A grade, given that she take course 1. And probability of the intersection would be calculated by taking the probability that she take course 1, multiply with probability that she got A grade, given that she took course 1. So that is for the intersection. But the probability in each of the branch here is conditional probability. If you have another branch here, it is probability of something given that she take course 1 and she got A grade. So just make sure you understood the meaning of the probability in each branch so that you don't create a wrong tree diagram. So back to the question. First one, we are interested in probability that Kate choose course 2 and she get an A. If we use multiplicative law, it will give us probability that Kate take course 2 multiply with probability that she get an A, given that she take course 2. In the tree diagram, we see that 2 and A is indicated by this path. So you can just take the number, the probability in each branch on that path and multiply them together. But in terms of notation, this is how you should write it out. So probability that she's gonna take course 2 is 2/6. And given that Kate takes course 2, then she have 40% chance to get an A. And if you calculate this number, it will be the final answer. Next one, we want to know probability that kid gets an A in the exam. Again, we will see that in the diagram, there are two possible ways that she can get an A, either through this way or through this way. So what is the meaning of each way? The first way means that probability that she take course 1 and she got an A. This way is when she take course 2 and she got an A. So I see that probability of A is equal to probability of taking course 1 and getting an A plus probability that taking course 2 and getting A. And it should make sense because course 1 and course 2 partition your sample space. We got probability that K takes course 2 and getting an A is the answer in part A. We are only dealing with probability that she takes course 1 and getting an A. So we see that happen in this path. So you can just take the probability in each branch and multiply them together. After you calculate this number, you add with what you got for part A, and it will be the final answer. Any question about this one? Probability of A, okay, let me see. So a student say that probability of A is probability of A intersect with the simple specs. Yes, this makes sense. And then he write the simple specs is taking course 1 or taking course 2. Okay, this also makes sense. And then you have probability of if you explain it out, this is what it means. AN1 union with AN2, and it will be probability of AN1 plus probability of AN2 minus the intersection. And this one is 0. So we just have probability of AN1 plus probability of AN2. And that should be enough to justify. Any other question? If there is no question, I will let you work on question 3 here. Again, 5 minutes should be enough. Here we start by drawing a tree diagram. You don't have to, but I just find it convenient for me. So I will draw 3 branch. The first one represents for the outcome when you examine the first tablet. And this column represents for the result when you examine the second tablet. And this is for the third tablet. And D stand for that the tablet is defective and N is non-defective. Initially, we start with 18 non-defective and 2 defective because we know that each box has 20 tablets. And we suppose a particular box contains 2 defective, which means it has to contain 20 minus 2, which is 18 non-defective. We start with these number. Then what is the probability that you get first tablet defective? And what is the probability that the first tablet is non-defective?
No, never mind.
Yep, that makes sense. So there's the answer from student 2/20 because you have 20 tablets in total and 2 of them is defective. And non-defective is 18 divided by 20. Next one, we move on to the result for second tablet that we examine. If we got first tablet is defective, then we are only left with 1 defective when we try to examine the second tablet, right? Then the probability that the second tablet is defective is 1 divided by 19 because you already examined 1 tablet. You only have 19 left that you didn't touch. So this is 1/19. For non-defective, it is 18/19. Similarly, I will fill in for this branch. If my first tablet is non-defective, then I still have 2 defectives. But I only have 17 non-defective left because I already got 1 non-defective out. Then in the second tablet that I examined, the chance that it is defective is 2 divided by 17 plus 2, which is 19. And non-defective is 17/19. If my first tablet is defective and my second tablet is also defective, then I still have 18 non-defective because I didn't get any of them at all. And I have 0 defective left. Then the chance that my third tablet is defective, given that my first is defective and my second is defective, is 0/18. And probability that having non-defective in the third tablet, given that your first 2 is defective, is 18/18. We can do the same thing for the branch here. So first we got 1 defective and 1 non-defective. Then the chance that we have defective in the third row is 1/18. And non-defective is 17/18. Move on to this branch. We have 1 non-defective and 1 defective. And here you have 2 non-defective. Any question about the tree diagram? If there is no question, we will start to answer 1, 2, and 3. Let's start with 1. We want to know probability that 2 defectives are found in the first 3 tablets examined. So if we look at it, each of the paths represent for one outcome. For example, this path here represent for all 3 tablets are defective. And this path represent that the first tablet is defective, second is defective, and the third is non-defective. So we are interested in the path such that we have 2 defectives found. So 2 defective found is the path here. Because we would have defective, defective, and non-defective. So it's exactly 2 defective. Another path would be defective, non-defective, and defective, like this. The third path would be, we got non-defective, and we got defective and defective. If you look at any other part, you will see that they do not have 2 defectives. So those are the paths that we are interested in calculating the probability. We are interested in probability that defective, defective, and non-defective, defective, non-defective, and defective, non-defective, defective, and defective. And in the exam, I still recommend you to write down the full formula for it using multiplicative law. But here, for the sake of time, I will use a shortcut. In order to calculate defective, defective, and non-defective, just take all the number on the branch and multiplying them together. It will give you the probability of that path. So I would have 2 over 20, 1 over 19, 18 over 18. And then defective, non-defective, and defective is this path here. I also start with 2 over 20, 18 over 19, and 1 over 18. The last path is here, 18 over 20, 2 over 19, and 1 over 18. And if you add everything together, you would get the number that you want. Any question about this part? If no, then we will move to the third tablet is defective. So you will see that there is a first way so that the third tablet is defective. There is a second way, third way, and fourth way. If you add everything together, it will be probability that the third tablet is defective. So we have 4 ways here: defective, defective, and defective, defective, non-defective, and defective, non-defective, defective, and defective, non-defective, defective, and defective. The first way, we just multiply all the probability together and you should get 0 because the numerator here is 0. The second one, we have 2 over 20, 18 over 19, 1 over 18. The path here, if you didn't see. The third one is 18 over 20, 2 over 19, 1 over 18. The last part is 18 over 20, 17 over 19, and 2 over 18. And again, you can just calculate the numbers and adding them together, you will get the final answer. Third one, we want probability that third tablet checked is the second one that is found defective. So it will be this way here because you already have one defective before that. And this way here. There are only two ways so that the third one is the second one that is found defective. And again, you just multiply all the probability in each branch together, and you would get the probability for each path, and you add them together. Any question about this one? If there is no question, then it's the end of our tutorial. There's still question 4 remaining, but I think that it is same difficulty with 3. So if you understood 3, you should be able to do 4. If you feel stuck, you can always ask on Piazza.